In this video, I'm going to share with you some basic ideas of doing calculation using logarithms. Right? In particular, I emphasize on the ideas of solving exponential equation. Okay? So this is very important means to help us to solve exponential equation and try to understand how the logarithms works. Now, before we do that, let's start with some basic exponential equation. I recall briefly what it means, all right, something like this. Let's say 4 to the power x equal to 32. That means we are interested in what happens when we take 4 as the base, raised to which power we'll get 32, okay? And you can work out the answers. And maybe I can also change the, even a simpler question, okay? On the right, you can change the original number a and b here, marked with the numbers. So what is 2 to the power x equal to 32? What is x? And maybe you can recall the powers of 2, then you can easily work out that 32 is just 2 to the power 5. So that means the unknown is 5. Now, but of course, this is only the basic one. All right. If you go on to some calculations like this, it is still x to the power x equal to 32 is still workable. Right? And of course, remember that we don't mean x times x equal to 32 here. Right? We're talking about x raised to the power x becomes 32. Now we can still ask the basic question: can we express both sides in terms of the powers of the same base? Right? Obviously, or maybe more easily. Okay, in this case, and if you recall that x and 32 are both powers of 2, right, then you can work out this relation: x equal to 2 to the power 3, 32 is 2 to the power 5. Right? It will help you to compare the index in this way. And then, okay, you can go on with the rest. The answer is 5 over 3. Right? So x to the power 5 over 3 is equal to 32. And it works because we know that x and 32 are both powers of 2. However, does it mean that we can only consider powers of 2? Actually, if you can freely work out powers of any numbers, then the same relations can be obtained. Right? For example, as an easy example to continue, and in fact, both x and 32 can be expressed as power of 4, although the powers now are not the usual integers. Okay, but the same relation is presented here. Right? The final answer is still x equal to 5 over 3. Okay, so the original question, x to the power x equal to 32, then it is the same x you obtain, no matter what base you choose to represent the numbers. So that means, and that's why logarithm becomes useful, okay? Because no matter what number you start with, you can always consider them as powers of 10. Right? This is what you usually get when you use your calculator, right? And calculate the log of any numbers. Then you will have the power, right? Representing what you get when you consider powers of 10 in order to get these numbers a and b. Okay, and so if you revise the same process again, it's exactly the same thing. Particularly, this line here tells you what we really need is this relation: x times the logarithm of x equals the logarithm of 32. And that's why you have this calculation. But of course, here I do not write all these things in terms of logarithm, right? And in your usual calculation, you may write down all this calculation directly in terms of logarithm. It's exactly the same thing. So that's why I put aside the logarithm on the right, okay, for you to consider. Once you can use the calculator, press the log button and get this exponent, then you can continue to solve exponential equation in your usual way if you prefer. That means everything are all in terms of indices, not directly in terms of logarithm. But of course, later on, if you're familiar with the logarithm notation or the properties, then this equation can also be presented in another common or useful textbook format. Okay. Now, this is the way we can consider solving. That's why solving exponential equation in general, can be done directly with logarithm. All right. So let's try another more general equation if you like. For example, we want to have this calculation: 6 to raise to the power x becomes 500,000. Okay, it looks like these two are not related. These two numbers, 6 and 500,000, are not related in any way, right? But in terms of base 10 logarithm, you can always find the index. Okay, so use your calculator to work out these numbers directly. If you are not confident with writing in terms of logarithms for the rest, then you can turn it back to indices again, just like what I write down here. Okay, it just tell you, the calculators tell you that 6 is 10 to the power 0.778, while 500,000 is just 10 to the power 5.699. Actually, you can see that the power seems not to be changed very much. Okay, but don't forget that if we are talking about tens, right, 10 as a base, then it's already quite a very big number, right, if the logarithm or the index turns to 5 point something. Okay, for the rest, so you can just go on with the calculation. So it tells you that the power, okay, here for the power of 6, you have to take 7.32 something. Okay, that means 6 to the power 6 to the power 7 something. Okay, will reach 500,000. Right, that is the meaning of the calculation. Okay, now so you can play with any numbers you like, okay, and try it out and then see how it works. Maybe finally, I just change it back to another usual types of problem. Now, because in our FD life problem, the base may not be common or the usual integers. In fact, it would probably be a decimals like this, right? And because we're interested in, let's say, certain percentage change, okay, which is also actually just a multiplier with a rather small amount, right? If you multiply something by 1.25, it means you're increasing the value by 25%, okay? And then you wonder when the result will be the same as, let's say, 200 times, okay? For example, you're interested in thinking about 25% increase, okay? And how many times to do so will you get an overall result of 200 times the original value? Now, that is the usual types of exponential equations that you come across in everyday life situation. For example, when you're calculating something related to money, okay? And okay, that's the same kind of process again, whether you want to work it in terms of the index form, or later on, when you're familiar with the logarithm notation, then you can work it out in a maybe more conveniently. But the result is just the same. It tells you that you have to take the index to 23 something, okay, in order to reach a multiples of 200. Okay? And of course, maybe in a more extreme calculation, right? So imagine that you are increasing something by 1% only, right, each day. How many days do you think you can reach? Okay, let's say the results of twice the original values. Okay, is it possible? Actually, it is possible. So no matter how small the values are, just like in this case, you're considering multiplying or increasing something by 1% each day. Then after 69 days or reaching about 87 days, then the total will be just double the original value, right? So that is the meaning of most of the exponential equation that you may come across. And hoping that you can work directly with the index or maybe based on the logarithm notation as well. But no matter what way you choose, your calculator giving you the log values already can help you to start doing the calculation, right? If you understand the basic principle behind exponential equation. And so by the way, when you are using this tool yourself or together with some other people, and you can concentrate on the logarithm values and do the calculation here, or you can also hide it if you don't want to show the logarithm at the beginning, but go on and start with some basic equations, okay, with convenient integers, then you can actually just put aside the logarithm for the time being, but later on, seeing more generally how the logarithm works, right, will help you understand also the basic ideas of the exponents, exponential equation. So maybe go ahead to have a try and then to see whether this tool will be useful for you. Okay.